Hey, hi everyone. Thank you for joining us today. So please note again, for those joining recently, we cannot hear you as you're all on mute. So if you have any questions during this webinar, please use the chat window. We'll make sure to address them at the end. We'll have an open Q&A session with the time that's left. Okay, so let's start by a quick introduction of our speakers today. So I'm here with Gary Steer. I'll let you introduce yourself.
Good morning or afternoon, depending upon where you're at. My name is Gary Steer. I'm GSX's CTO. And prior to coming here, I've got a long career in Microsoft Exchange type areas. So I was a certified master, or a ranger they used to call us, and an Office Servers and Services MVP, which used to be an Exchange MVP. And live.
Yeah, thank you, Gary. So my name is Olivier Renaud. I'm based in Boston. I'm responsible for our client satisfaction team. So at GSX, all the technical team helping our clients from the deployment to the day-to-day and client service. I have a heavy focus on Microsoft, mostly on the messaging side, Exchange and Office 365. So some of you have probably come before to this technical webinar series. So really the goal today is not to show you any of the GSX products, but talk about some particular technical comparison information that we wanted to present to you. What we're actually going to talk about today has been requested by a lot of the previous attendees. So really the goal is to have a technical format. We won't spend too much time in PowerPoint. It's going to be an easy flowing format, and we're going to focus on data. That's what we like to do with Gary, sit and look at some data. So what we've done today is to look at MAPI over HTTP. We've heard a lot of things around MAPI. That's something you've heard for a long time now. So we focused on that today. I won't say too much. Just make sure to come back in the future where we'll address other topics. In the past, we've done studies on proxy servers. We looked at express routes. We looked at some DNS configuration. So we'd like to understand what's causing performance, how you can improve, and what control you can have. So in the future, we have a few good ideas to test Skype, test UDP versus TCP. There's been a lot of discussion on Teams. Now that starts to be used more by many companies, so we'll do some comparison on Teams and Skype. But if you have any interesting topics that you would like us to cover, please send us some feedback, give us some requests. We'll be happy to address those topics. So quick agenda for today. So we'll do an introduction on MAPI over HTTP. Gary will give you some bit of history background on what happened. We'll then look at the difference between the previous protocol, RPC over HTTP. And then we'll focus on the experiments. So we'll explain what we've tried to achieve, what we've actually done, and we'll analyze the data together. And then we'll, as we go through the data, explain why, explain what are really the impacts for you, what you need to do, why this change happened, and we'll take a few questions on that.
So I figure I'll jump in here and talk about MAPI. Although we're talking about our session being MAPI related, MAPI over HTTP specifically, the term MAPI comes up very frequently, and it actually dates a lot older in terms of technology itself. So, MAPI, it means the Messaging Application Programming Interface. It, came out way back, but informally, 1991, MAPI 0, if you want to call it that, was released for MS Mail, but then we ended up on moving into probably the first formal release of MAPI was 1992. So this has been around a while. It was initially designed just to let a local mail client, something built into Windows, talk to a mail server running on, initially again something running Windows in that same network. The key thing there that I said, though, in the same network. So a problem with MAPI is that it really was designed to be used on your network. It wasn't designed to be used outside of your network. So we ended up in a situation where we had to take a look and figure out a way to make MAPI work uh, in a better fashion, in a capability where we had oops, I know it looks like my audio is dropping out a little bit there. Uh, Hey, Lev, I don't know if you want to jump in and grab that one. I can switch to a different headset to see if that helps any.
Yeah. I think some people noticed there were some cuts. So yeah, but so I think it's important to notice that MAPI has been around for a long time. So that's what everybody knows what MAPI is, but there has been a lot of different flavors to it. So we're not going to go through each of them historically, but most of you know the protocol before that was RPC over HTTP. It was really still MAPI, just layered with RPC first, or wrapped with around RPC, and then wrapped with HTTP to be able to be what we know of Outlook Anywhere that lets you connect from the different places. So we won't drill down too much into that diagram, but what I thought was interesting noticing is really the kind of complexity and number of calls that happen here. So first, as you can see on the right, the fact that it's kind of double wrapped, this MAPI like core protocol, double wrapped around these two. And it required multiple connections. So it required two long-lived TCP connections for each session between the Outlook client and Exchange. So no matter if it's Exchange servers or Exchange Online. And you can see the different calls here. If I switch to the next one that's MAPI over HTTP, you can see here we have less of these requests. There's no longer requires these two long-lived TCP connections to be open between Outlook and Exchange. Will actually generate a maximum of two current connections, generating this one long-lived connections. And you can see it's a more traditional HTTP payload. It's a typical request response. So that most of you probably already know that, but it's much easier for managing and administrating this protocol because it's now single wrapped and a more traditional HTTP protocol. The other thing with HTTP is that it decouples the client server session from the underlying network. So when the network connection is lost, the session itself is not reset for 15 minutes or so, and the clients, they can simply reconnect. So that was one of the things as well that we wanted to test today, is kind of test when we go hard on it and on the network and test the reconnection. And so then the purpose at the time, I mean, that started 3-4 years ago. There was still some on-premises systems, and the scalability on the server side was also improved because reestablishing a lot of these RPC over HTTP connection could have strained the resources on the mailbox servers at the time. So a benefit on the architecture.
And not just even in strain, the configuration was really, it could be complicated if you had to set up RPC on 10, 15, 20, 30 different servers, that were sharing the same name. That was a lot of work.
So let's go to the experiment. So what we've tried to do, and so like the previous session, we like to take different use cases, make some tests, and gather a lot of data, because only with data you can really understand what is the performance impacts, where there are some improvements that can be made. So what we've done is we've taken 3 use cases. We wanted to compare in these different use cases, MAPI over HTTP and RPC over HTTP, from a performance standpoint. That's one of the things that we like to do best at GSX. So we've taken these 3 examples that you can see on the left. Our first deployment was on Windows 10 clients with Outlook 2016. The second one was the same, but just we'll explain as we go over the data, but we've been really hard on the network. So we've tested a lot of different network, the packet loss, latency, so we'll explain as we go on that. And we also tested on Windows 7 and Outlook 2013. We wanted to do something modern with Windows 10 and 2016, but we know there are still a lot of companies out there that are using Windows 7 clients. OS and various type of clients on top of that. So let's go and head over to the data. Okay, so what we've done, just to explain and give you some context, we've deployed, so on each of these use cases that I've just explained, we've deployed what we call robot user. The idea is that they perform tests over and over again. So the idea is to simulate the user. So we've gathered the data this way by automating this connection. And every time for each use case, we had one machine doing RPC over HTTP, one machine doing MAPI over HTTP. So what you're looking at here is a dashboard that gathers several days of these metrics. We have each of the actions that can be performed from an Outlook client. So we've looked at the open mailbox. That's really the full auto discover. So to retrieve all of the different settings, connect to the endpoint, authenticate, and get into that mailbox literally, so retrieving the different properties. And then we've done various actions such as creating a meeting, creating a mail with an attachment, doing a download attachment of a 1 megabyte file. And we looked at the various results from each of these. So here you see the different results. What's important to note is here you have the different graphs for each of these actions. There's just some controls to make it faster today. I've already opened 3 tabs for each of the use cases. So here, this is the one that we haven't done any particular modification. This is a machine that is in France. It's 2 machines in France, 2 client machines. They're accessing the messaging in Europe as well, actually on Office 365, and we've compared the different actions. What we expected to see, since the protocol allows to better reconnect to an Outlook to a session, we expect it to be faster, and that's what we've seen on the open mailbox. So as you can see here, there's about a 20-25%. It's about 20-25% faster to establish the connection to the mailbox, in between the client to the mailbox on MAPI over HTTP rather than RPC. However, what we've seen is, and we're a bit surprised, but what we've seen on all the different actions is that it was actually a bit slower to do MAPI over HTTP than RPC. So you can see that here on the different actions. You can see here it varies in between 5 to 20% slower on the MAPI side.
So one thing I think we should just take a quick second and call out, as we're doing these scenarios, we're running them on virtual machines that are not being disconnected from the network, not running on wireless, not suffering from whatever could go wrong at home when your kids are streaming games across the internet or Netflix or whatever it may be. So the areas where the MAPI protocol may help, it's possible that we're not hitting those at this point, but we really wanted to take a look at the raw protocol itself in a very static configuration. What does it look like?
No, so that was the first set of data, and the other thing that we can notice on the right, you see kind of, so we looked at the variance and standard deviation. What this really shows is kind of the stability. So you can see it's a dramatically different in between MAPI over HTTP here and RPC over HTTP. So the connection seems to be much more stable, not varying as much on MAPI than on RPC. So kind of acknowledging the fact that it looks from this standpoint on this set of metrics of data of a more stable protocol and initiating the connection to the messaging service much faster, but not necessarily the case on all the actions. So then we've done the test on, so that's the last actually one, the Windows 7 and Outlook 2013. So what we've done here is the same set of tests. These were 2 client machines running Outlook 2013 SP1 and connecting to the messaging. On the performance side, we've been surprised, but we've seen different sets of results. On this configuration set, the connection time and the different actions varied a lot. So depending on the time frame that I will take, you will see sometimes RPC being performing faster, even on the initiating the connection. At the opposite, on the different actions, MAPI seemed to perform a bit better. However, the thing that we can acknowledge here again that confirms the first assumption is that MAPI is more stable. Again, you see a big difference in the variance and standard deviation for MAPI as opposed to RPC. So then, this was when we thought it'd be interesting to play on the network, have different environments were produced. So having some packet loss introduced, some latencies. So we actually chosen two machines that connected this time from the US to an endpoint in Europe. These two machines, we've done various tests, but I can tell you, Gary and I had fun trying to really be hard on the network. So doing things like just adding latency, adding some packet loss on these machines. We've played with some throttling, packet duplication, packet out of order, some temper. So there was a lot of fun that we've had. We've been really hard, and we've tried to simulate something realistic. That's what we end up doing, having something realistic, a slow packet loss, some added latency. And here it confirmed the first set of data that we presented to you. The connection time was slower for RPC, so it was faster to do MAPI. You can see it's not drastically different, but it confirms what we've seen in the first set. On the actions, yeah, go ahead.
No, I was going to jump in. You can finish that one off because I have a slightly different take on this data that confuses me, but go ahead. You can finish, and then I'll.
I was going to say it's similar to the first thing that we've seen. So when we had the stable environments, and here with the different packet loss. So the metrics we're currently looking at is for a 5% packet loss. It's 50 milliseconds latency added, knowing that it's already going across the Atlantic, so there's added latency there. But so yeah, the open mailbox was slightly faster, not the actions, but now we're not really talking anything above a 10% difference. So pretty similar in terms of just looking at the latency itself, the time it takes for these different actions.
So I think what confuses me about the results that we pulled out here, and then maybe it was just an assumption I had that from things I've read, from detail that I've seen come across on different DLs that I belong to where I expected that we would be in a position to where we'd find this this magic scenario where MAPI was just MAPI over HTTP. So again, when we're using that term, we're just being sloppy, but where we would find MAPI being much better than RPC, because we would expect that it was designed for better resiliency and that we could replicate a running scenario, not just a reconnection. It clearly, we've shown it reconnects better. We were able to find that in a few scenarios, but we went from from a normalized, I guess, damage scenario like Oliv is talking now. But we had a router we were taking down, for 2 seconds out of every 6. I put a proxy server in the middle that was throwing away packets. No matter really what we tried, we struggled to actually come up with a scenario where, other than much better at reconnecting the mailbox, the individual tasks, I don't think we found anything that performed quicker when it was MAPI.
Not during these tests when we're causing chaos or just like packet loss and added latency. There's one thing that we looked at, Gary, that was like on the different packets that were exchanged and the volume in terms of number of packets and kilobytes exchanged.
Yeah, I think the other really interesting thing. And hang on, one question popped in. These are all tests run in the last 2 weeks against Office 365. So there was a question on whether we were doing this against, I presume, on-prem or the cloud, but all Office 365 testing that we're doing. So the other interesting thing that I don't know, sometimes when we look through this data, we find something, we love it, it's fantastic to look at, it's amazing what it shows. I'm still trying to figure out how this is happening, but when I look through these two, the Philly servers are running out of my lab environment. I've got a reasonably high-end firewall that I isolated the amount of data coming out because I figured, MAPI must be a thinner protocol. It must send less data. I can tell you it established less TCP sessions so that I had fewer sessions, but I had a lot more data going. Depending upon what it was, like sometimes twice the amount of data volume that was moving. So if it was 2 megs coming out of an RPC session, it was 4 megs coming out of a MAPI session. The thing that's incredible to me is when you look at the fact that this was literally needing to move twice the amount of data at times, it was, within 10% of the actual performance. So it is in and of itself a very efficient at moving the data in the way it wants to, but that doesn't mean smaller. I think we want to be very careful to understand that a packet, this protocol has been designed for a purpose. It has been designed for better resiliency. It has been designed for something other than smaller amounts of data. So I think that's a key thing that everyone should understand. It's not meant to be thinner. Very clearly, that's not its purpose.
No, indeed, yeah, we had a lot of discussion, and we're always looking at the performance standpoint. I think the results here is that the change has not an insane difference in terms of the performance for the different actions. It's just and somebody called it out in the audience, just a transport efficiency, a more stable protocol. There are some improvements on the connection, but we haven't been able to really confirm that a lot. There are also some throttling that can happen in Office 365. I think there is a lot of room for improvement on the client side. We've seen in the previous webinars, on these technicals analysis, that there's a lot that you can impact depending on what goes in the way on the connection and from the client standpoint. But do you want to add anything, Gary, or should we go to the?
No, it's a side question for one of the comments that came in about, MAPI being slower than RPC hitting shared mailboxes. I would be curious on the Outlook version. That's just a side question after what it can take to properly patch these and get them running. But no, I think it's valid to really understand, in some ways where the change is a big change potentially, and in other ways that the underlying communications are they're well defined. They've been there for a long time. That they've been refined very well. So it's we're really, no matter what kind of torture we gave this, it's splitting hairs, which I think is another good thing to know. I mean, it's not less stable. And in our testing, like I said, it reconnected better, although I think all of these things are environment by environment by environment at the end of the day.
Yeah, there's a lot of that. We've heard different feedback from different companies, different users. I mean, the change to MAPI is happening. If you're on Office 365, that's the protocol that you're most likely already using. And you're on premises, moving to Exchange 2016, that's the protocol that you want to use. So there are a few things to consider. I think from a protocol standpoint, MAPI over HTTP is more aligned with the modern world. Nowadays, we're really connecting from different networks, home networks. When you're in-flight networks, cellular networks. We connect from various different locations. The modern workplace is much different than what it used to be 10 years ago. So the reconnection, we've been able to see that it was faster, not on each of the different actions. We've had some feedback, and here again in the audience, some attendees said that when they moved to MAPI, it was not faster, it was slower. I think what's critical is to measure and understand. If you're implementing any change in your environments, or if there are some change that will happen that you don't necessarily control, like when you're on Office 365, MAPI is a reality. You must adapt to it. You need to do some careful planning and gather metrics. It's critical to be able to have visibility and understand what is the current performance, what are the changes, so that you can understand when, with all the parameters that you change, what is the impact.
To one of the questions that just came in. So, are we saying that we should expect to see greater volumes of data for the same actions when we switch to MAPI? My only hesitation here is I don't believe that the test battery that we do, typically it's the problem with any of these type tests is you really need to see it in your environment. You need to see what your users are doing, and you need to have a piece of technology that can accurately advise you in your environment what you're doing. And watch what's taking place in your configuration, because in ours there are some things that are set up well, some things that are set up terribly. I know our auto discover is needs some adjustment, but every single thing I've looked at, I even went to the point of assuming that my firewall logging was something was wrong with it. So I purged all my logs. I rebuilt my firewall rules to have specific rules that would track my traffic to and from Office 365 endpoints, so I could log just those. And I'm seeing about 210% data utilization on MAPI. So I'm not at the bottom of it yet, but I can't find anything that says it's smaller. So would I say to plan on that? I think it's fair, and I think even the public-facing documentation from Microsoft is clear that this may be a little larger. I would consider double that we're seeing in my environment right now to be more than a little. I would not consider that to be conclusive, though. I don't have enough data points to feel safe about it. But combining what I'm seeing with Microsoft's public-facing documentation, I would say that you should assume that you will see an increase in bandwidth. But assume is the key word. I think you want to test this. You really want to run a scenario, see what the change is if you run the exact same configuration, the exact same battery in your environment using one protocol versus the other. And you probably want to do those tests sooner as opposed to later, because I don't know how long you'll be able to actually get that data against Office 365.
Yeah, I've seen that there was another question on how can you find out if a client is currently doing RPC over HTTP or MAPI over HTTP. I can just show you a quick way to do it. It's actually pretty easy when you go. So this is one of the clients that we used for making this test. On the sys tray, if you right-click with the Control-Shift key on the Outlook icon, you can actually have a new set. So normally you just see that. With the Control key, you'll see a couple of other things that like test email auto configuration and connection status. Connection status gives you some great information, and this is where, since Outlook 2013, Microsoft has added this protocol columns that will let you know if you're doing currently RPC over HTTP or if you're doing MAPI over HTTP. So RPC would show up like this. This is a machine that was doing RPC over HTTP. The MAPI would just show HTTP. So that's a way that you can do. This is only in Outlook 2013 and Outlook 2016, though. We're not going to be able to find this column on Outlook 2010.
As a side note, all of the testing we've been doing has been in online mode, quite intentionally, just to see if how it performs, and we don't want to cache causing any issue as we run a test. I have read mixed results from people that some of which say in a Citrix environment, for example, MAPI over HTTP is um, a great way to have this work better. Other ones that say on Citrix it's slower. So it's incredibly. I think this is the kind of topics we like to pick. We like to pick these ones where you can't get a it's just not so easy. It's always some kind of an issue that we're stuck against here. But we did run them in online mode. It's interesting though. The data volume is the one that has me, and that data volume is higher. I don't know if you caught this, but on fewer TCP sessions. So I'm going to kind of take some time and tear that apart more because I find it interesting. But it certainly seems like that there's going to be more volume. I think is a safe assumption.
There was another question on what versions of Outlook can do MAPI over HTTP. So basically, Outlook 20, so all versions after Outlook 2010. Although you do need to have the right updates. We've done some tests with Outlook 2010. If you want to do MAPI over HTTP with Outlook 2010, you actually need to roll out the Service Pack 2, and there's about around 10 cumulative updates that you need to manually apply. So that's a lot of work if you want to get Outlook 2010. And I think that's the reason why there are still many companies doing RPC over HTTP. If you're on Outlook 2013, you just need Service Pack 1, and Outlook 2016 will do MAPI over HTTP.
By default. So unless you've actually taken the time to put a registry key in that re-enables RPC, all of your 2016 clients would be doing MAPI already.
Exactly. I would recommend not changing that registry key unless you're doing some tests like that. So yes, the recommendation I think is if check what you're currently doing, check your environment depending on the versions that you have rolled out to your end users. Check what protocols are in use. It is best, obviously, to update them and get ready for MAPI over HTTP. If that's not already the case, you should definitely take a look and plan for it.
So one question that came in. I know we're running a little over on time, but I think we always do. There's a question that came in on again someone who's using remote desktop services, and they're saying that Outlook is slower because it runs better in RPC, and that there was a note that Microsoft is ending support for RPC on Exchange Online. So the informal publish date has already passed. It is, I'm as I think you saw when Olive pulled up the connection status, we are currently connected. Clearly, some of the people on the webinar are still connected using RPC. Too many sessions were still active, so Microsoft had to hold off ending that support. It'll be interesting to see what happens as things move forward, simply because Exchange 2019 is really planned to ship without it. All of these Exchange versions anymore are smaller incremental upgrades, but we will see if they can actually take that position and move forward. But so I don't know. I don't know because of the change in the public guidance. I haven't seen anything public facing that gives a different date yet. I've been on a few NDA covered calls that they're working on a plan. I really can't say much more than that, but it is a goal to end it. One thing I do want to point out though, if you're one of the bigger benefits of MAPI, quite honestly, comes down to things like better modern authentication. So if you're doing multi-factor auth, even if this performs a little less efficiently, you still may want to take a strong look at turning it on anyway. It's not just the performance that matters. Yes, you want to plan for that, absolutely, or you'll get tickets anyway, but make sure you understand the total impact of not moving to a newer protocol. If you've ever been in a scenario where, on a legacy protocol with Exchange, you've got to terminate a user for whatever purpose, and you want to, close their mailbox, and you've got an open ActiveSync connection, there's a really long lifetime to that connection, even after the user has been disabled. So there are, some security holes that the newer protocols help you start to plug to make sure that you are just being more effective and more efficient, more secure. So there's just, I guess my point is, consider this holistically. Look at the benefits you get from the newer protocol compared to the impact. And maybe it's not necessarily right for your environment based upon your mix of shared mailboxes, with delegate access that you may be doing between different individuals, but maybe it is, and maybe you'll find a subset of your users that when they're roaming completely outside of the corporate network, it's a great fit. I think you need to do a full evaluation, but I also think that you probably shouldn't count on less data.
No, indeed. I think we're already over time, so we want to thank all of you for joining the webinar. We had some great discussion, and thank you for all these questions. If we did not get a chance to answer your question today, we'll get back to you in the future, so don't hesitate. Leave us some feedback after the webinar. We would love to hear about your thoughts, your feedback on today, and if you have any topics that you would like us to look at and analyze, we'll be happy to do that.
And we'll go through the chat because there was actually a lot of conversation today. We couldn't keep up with most of it. So we will, if we miss responding to you, we'll get a response out by email.
Yep. So thank you, everyone. Thanks again for coming to the webinar. Have a great rest of the day, and we'll meet again soon.